Production Robotics designs and builds specially engineered, state-of-the-art manufacturing and process equipment. Equipment developed by Production Robotics can be found at work in a variety of industries, including biotechnology, food processing, manufacturing, and pharmaceutical packaging. No matter what the application, Production Robotics will build the best possible machine for the job. Production Robotics designs, builds, and tests all of its machines at this modern facility in Oakland, California. Here, senior automation engineers analyze customer requirements and develop special machines to meet customer needs. Many components are fabricated on-site using Production Robotics in-house CNC equipment. Attention to customer needs and solid investment in the equipment necessary to support those needs enables Production Robotics to deliver the highest possible quality products on the aggressive schedules that customers demand. Production Robotics knows that customers expect their machines to provide many years of trouble-free operation. That's why its design strategy incorporates a number of features to produce machines that are easy to maintain and highly reliable. Features such as sealed and permanently lubricated bearings, the highest quality hardware, components, and sub-assemblies, and low-stress design. President and Chief Engineer of Production Robotics, Leonard Ginsberg.
What makes Production Robotics special is our commitment to thorough engineering and quality manufacturing. We build every machine to last many, many years with very little routine maintenance.
Production Robotics designs all new machines using SolidWorks solid modeling software running on high-powered engineering workstations. Only after the virtual machine has been fully approved by the customer is the actual equipment built and tested in the Production Robotics laboratory.
We build the best machine that can be built for the job. We investigate your situation and your production process thoroughly and build the machine from the ground up to work flawlessly on your production floor. You get a machine that runs like clockwork year after year, cranking out the goods that build your company's bottom line.
The right equipment can help you meet or exceed production goals and maximize your profits. In this video, you'll see a collection of diverse machines that are working hard for customers right now. Thanks to Leonard Ginsberg and the Production Robotics team, these customers now have the tools they need to work better and smarter. When most people think of biotechnology, they may visualize test tubes and beakers being attended by lab-coated scientists. But modern biotechnology research often resembles a factory assembly line. By automating parts of the scientific process, research organizations have been able to dramatically increase the pace of research. Many biotechnology experiments are conducted on microplates, which contain individual wells that house experimental materials. A prominent biotechnology company needed a machine to insert porous filters known as Fritz into microplates containing 384 wells. These wells are quite small. Nevertheless, the insertion needed to be highly repeatable, precise, and error-free with a throughput in excess of 200 Fritz per minute. 2 interchangeable nests hold 6 plates each. A plate is placed on the nest, and when the operator flips the lever, the plate is locked into position with X and Y axis. Repeatability better than 1/1000th of an inch. The next part of the process is manual, and Production Robotics began by ensuring the safety of the machine's operator. Here we see the operator loading a tray of 6 plates onto the machine. To protect the operator, Production Robotics installed a light curtain. Should the operator violate the light curtain, the machine will come to a nearly instantaneous full stop. 2 mirrors above the feeder bowls enable the operator to monitor the contents of each bowl. Once the tray is in position, the Fritz are metered into a carousel and optically measured to a resolution of 2/1000ths of an inch. Any Fritz that fall outside this tolerance are vacuumed out. At the next station, an LED sensor determines whether a Frit is available. The next step is inserting the Fritz into the well, a task that requires a high degree of precision and repeatability. Production Robotics met this manufacturer's requirements by designing a special head with 2 drive pins. The first inserts a frit flush with the tray. The second drives that frit precisely 1/8 of an inch below the surface of the well. After the head advances again, another sensor confirms the presence of the frit in the well. If no frit exists, the machine backs up and repeats the installation. This precision and repeatability occurs at high throughput. The Production Robotics machine inserts 240 frits per minute, completing a tray in less than 10 minutes. The frit injector application required Production Robotics to focus its development and design efforts on precision and speed. But other industries have different requirements. Food processing, for instance, puts a high premium on quality and presentation. The Don Sumor Bakery needed to greatly increase production to meet demand for its popular madeleines. When the bakery consulted Production Robotics, it was producing over 250,000 cookies per week, and demand was continuing to grow. While the bakery recognized that it would need to automate some processes to increase production, it didn't want automation to impact the craftsmanship and quality of its confections. Don Sumor took great pride in its old-world feel and wanted to preserve this character while meeting its increased production demands. Production Robotics responded by building machines that facilitate, rather than take over, activities that the bakers once handled manually, such as inspecting and packaging cookies. This machine dispenses batter and butter into specially designed trays. Production Robotics built this machine with a minimum number of moving parts and no O-rings that need routine replacement. All bearings are permanently sealed with FDA-approved grease. There are no lubrication points. The result is a reliable, low-maintenance machine that has dramatically increased both throughput and the quality and consistency of Don Sumor's product. Because increased throughput had overwhelmed Don Sumor's manual packaging line, the bakery asked Production Robotics to develop a high-speed bagger. This machine works with trays as they come out of the oven, eliminating one unnecessary handling step. Instead, with the push of a button, an entire tray of cookies can be bagged. These keepers lock the cookies in place so that the baker can inspect them on both sides and replace those that don't meet Don Sumor's standards for size or color. When the tray is approved, the keepers are released, and the cookies drop into these 6 chutes, where they are metered into bags 1 row at a time. Vacuum cups hold the bags open until they are filled. Filled bags are then delivered by conveyor belt to the final packaging station. As the tray of cookies is being flipped over, a light curtain is activated. If the light curtain is violated, the machine will come to a nearly instantaneous full stop. While the bagging machine contains both a compressor and a vacuum pump, Production Robotics took care in the design to keep the machine compact, fast, and quiet. This minimizes the impact that such a machine could have on the bakery's environment. Some of Don Sumor's customers require that the cookies be supplied in jars, so Production Robotics built another packaging machine for this purpose. Again, bakers are able to inspect the cookies and replace any that do not meet Don Sumor's standards. When the entire tray is approved, the baker releases the lever. All 24 cookies drop into jars. The baker then uses a foot pedal to gently shake the cookies so they settle into the jars. The intelligent tools developed for Don Sumor achieve the throughputs that will support the bakery's current and future production demands. More importantly, the machines will enable them to maintain the craftsmanship and the quality that has built their reputation and created the demand for their confections. Precision, quality, cost. All these factors can influence a customer's ultimate satisfaction with a piece of equipment. Production Robotics looks closely at the particular application for a machine and works with the customer to achieve the right balance in these areas. Take basketball hoops, for instance. A manufacturer of basketball hoops asked Production Robotics to design a machine that would weld the 12 hooks for the net onto the hoop. And the process here was quite different from that necessary for a highly expensive biotechnology assay or even for the production of high-quality confections. For instance, the inexpensively manufactured hoops used by this manufacturer were inconsistent in shape and size. In addition, even though the hoops were covered with rust and scale, the manufacturer did not wish to clean them. Cleaning would introduce an additional handling step and would increase costs. And for this manufacturer, cost was a key concern. Production Robotics was called in to develop a machine that could handle the inconsistent quality of this manufacturer's materials while still producing a sturdy, robust final product. The machine fully automates the process of welding the hooks onto these hoops. Hoops are placed in a stack and metered one at a time. The hooks are fed from this bowl to these two welding heads. The machine positions the hoop and the two hooks and performs two welds simultaneously. Then it rotates the hoop and welds the next pair of hooks into place. When the machine completes a hoop, it drops it onto this tree. The tree can hold up to 40 hoops. When all 4 arms of the tree are filled, the machine automatically stops. Production Robotics designed this flash welder for a customer that wanted a machine that could handle more than one type of weld. Gates and guardrails, which this customer builds for its clients, require intricate shapes that can only be produced by using different welds, such as T-welds and butt welds, in combination. Flexibility in this case was key. The specially designed flash welder has retracting clamps so that there are no obstructions on the surface. The flat surface gives welders the ability to select the type of weld they need at a given location. Production Robotics has developed a number of different machines to assist with various aspects of pharmaceutical processing and packaging. A company that specializes in drug delivery systems needed a machine to speed its research in absorption control. One of the mechanisms used to control the absorption rate of the medication is the coating applied to pills. The entire pill is coated, and then additional stripes of coating are applied to gain greater control of the absorption rate. In the early phases of this research, the coating and the stripes were applied by hand. The customer asked Production Robotics to build this machine to automate the application of stripes onto the pill. Because the thickness and the width of the stripe impacts the absorption rate, this customer demanded a high degree of control over the process. Operators needed to know with certainty how the stripe was being applied and how much was being applied. Production Robotics met these requirements with a machine that puts the operator in control, yet the process remains automated. First, the operator fills the reservoir with the liquid coating. The pills are loaded onto a carousel, which then positions each pill so that a stripe of the coating may be applied. The customer then asked Production Robotics to build this enhanced version of this machine. In this enhanced version, a peristaltic pump continuously circulates the liquid to ensure a consistent mixture. The enhanced machine gives the operator complete control over the process. Using the thumb wheel switches on the face of the machine, the operator can regulate the speed of the carousel, the length of time the carousel pauses at each location, the temperature of the liquid, the temperature of the hot air used to cure the pills, and the length of time that the pills are cured for each batch. By carefully studying the details of this customer's process, Production Robotics delivered a machine with the flexibility, precision, repeatability, and control to support it. Another customer required a machine to fill a capsule used in a unique aerosol drug delivery system. In this process, a blister is formed in the lower film and filled with a predetermined amount of liquid. The top layer contains a set of precision nozzles for distributing the liquid. The layers are heat-sealed together, and the final device is punched out. Because the device operates only when the blister and the nozzle are properly aligned, the process is monitored using a number of registration and alignment mechanisms. Production Robotics controlled precision and quality in its machine with a high-resolution optical sensor. The sensor checks registration marks on the top and the bottom layers after assembling each card of 20 parts. This check automatically re-registers the blister-forming, heat-sealing, and punch-out stations. By re-registering all major stations after every card, the Production Robotics machine maintains consistent, high precision of product assembly. The right machine can not only make processes more efficient, it can save money. This multivac pouching machine can fill 4 pouches at a time. However, if the machine improperly filled one of the 4 pouches, all of the pouches were rejected. Naturally, the wasted material discarded by this machine was creating an unnecessary expense that the manufacturer using the machine wanted to eliminate. Production Robotics was asked to design and build a machine that would sort pouches as they came off the multivac. By separating good pouches from those that had been filled improperly, the customer could lower costs while ensuring steady throughput. As the pouches come off the multivac, they are collected by the sorter. The sorter receives information from the multivac and drops the pouches into one of 3 bins, one for good pouches, one for pouches requiring rework, and one for rejected pouches. It's a simple process change and one that is easily automated. In this case, it also has saved this customer a lot of money. This manufacturer needed equipment to manufacture and package a blood diagnostic kit. The custom machines had to produce consistent parts and operate for long periods with low maintenance. This specially designed laminator bonds several layers of filters and membranes together. It then slices off a strip of the resulting laminate, an 1/8 of an inch long, and places it on the diagnostic cassette. The strip has a tolerance of 2/1000ths of an inch. This machine has been in use for over 10 years, and in that time, only the cutting blades have been replaced. The same manufacturer also required the pouching machine to produce up to 40 parts per minute. In addition, it wanted a low-maintenance machine that would gently handle the delicate parts associated with the kit. The machine first removes pouches from the stack and places them on a conveyor. In the production facility, cassettes can be fed into the poucher by an upstream machine. The cassettes are then dropped one at a time onto this receiver. Jaws clamp the part while the shelf retracts. These suction cups open the pouch, and the jaws carefully place the part into the pouch.